In this video we're going to look at rotations. Let me remind you of something, that when we had a translation we had to specify what vector we wanted to translate by. So we might use a T for translation and then give it the vector. For example, in component form I could write this to indicate the translation by the vector 3, -2. Or we might give a translation at 5 and then maybe 20 degrees, or we could give it in radians, or we might say, 5 centimeters, 0.82 radians, to specify a magnitude and a direction angle, or we might give it a vector there. So that's defined by vector. Now we've got two transformations, two isometries that begin with the letter R. We've got a reflection and a rotation. So I'm going to use R for a rotation, and for a reflection I'll use M for mirror. And of course mirror, we have to specify what line, the line L, or we might give the equation for that line, y equals 3x plus 2. And this tells us this defines our mirror line. Or we might give it the line, say the line AB, or we might say the line going from 3, 2 to 4, 7. But this, somehow we've got to identify that line that's our mirror line. Okay? When we have a rotation, we need to define a center and an angle, or amount of rotation, a center and magnitude. So we might say about the point 3,4, and we might say an angle of -35 degrees, or we could give it in radians, right? A rotation about the point -1,2 and about -0.56 radians. So we give a center and an angle. Okay, so in Sketchpad we can take a point, say this point, and say we go to transform, we can mark that as the center. And then we can take our figure we want to rotate and we can say transform rotate, and we can give it an angle. This is going to be an angle, let's say we do an angle of pi over 6, let's say, and that's going to be our rotation. Okay, so let's mark our image points down here in red, as we usually do. Okay, what if I could do this by a parameter instead? For example, I could go to create a new parameter. Let's call it angle of rotation or magnitude. How about just angle? And 1.2 radians or something like that. Okay. And so now I can click on that and say transform, mark that angle. We've already marked this as the center. So if we identify our pre-image here and say transform rotate about the marked angle, and we can rotate there. It's down here. Let's turn it red. It's off the screen. Let's pull this in a little closer so we can see that. So we can see this thing rotating about there. So B goes down to here for B prime, A goes to here for A prime, and C goes to here. Notice what happens if we connect up pre-image and image. These lines are not parallel like they were in both the translation and the reflection. In the reflection, the lines here were all parallel and perpendicularly bisected by the line of reflection. In the translation, they were all the same length in parallel, because they were basically the same vector. Here they're going at different angles with the horizontal, so something's happened a little bit more different here. So let's get rid of those. Well, look what happens if I draw a circle to C. It also contains C prime, and the A goes to A prime, and likewise here, if I drew that in the right place, to B, it's also going to go through B prime. So notice that the distance from center to pre-image is the same as from center to image. And if we measure this angle, C center C prime, look what happens. It's the same as the angle that we had. A center A prime, measure the angle. There we go. And B center B prime, measure that angle. So whether you're doing it from A, B, or C, when you connect pre-image to center to image and do that angle in that order where the angle is at the center. In other words, what I'm saying is this angle here, when we actually make the actual angle, that was to B, so that angle there has the measure of this amount here. So that's what's happening here. This one here is controlled by an actual angle that's here, and the center is the center of the vertex of the angle is the center of our rotation, and so we're thinking of spinning this around here. It does make a difference which direction we spin it, if we spin in the negative direction or the positive direction. And so we know that if we draw circles centered at the center of the rotation, which is this case is the vertex of the angle, we know the images will be on there. So the image of E is on here somewhere. We're rotating. Notice we're not rotating. You don't rotate left or right or up or down. You rotate clockwise or counterclockwise. Or in the counterclockwise is positive direction, clockwise is negative direction. So here we're rotating. If we think of starting down here and then rotating this way, we're rotating in a positive direction. So going in a positive direction would put E prime over on this side, D over here somewhere, and F over here somewhere. Okay? Now, we also know that, so the actual arcs they're going to travel, if we think of putting this in motion, and we show, we actually animate this, it's going to be moving along those arcs like that to a final image right there. And so, for example, if we look at the moment from E to the center to E prime, we get the same angle there. Okay? Another way we could do this is to set up a parameter here, set up an angle, and the new center of this new rotation goes here, mark a center and an angle. That's the way we did on the other sketch. Now, how is this going to help us do a compass and straight edge construction? Let's see if we can figure that out. Okay, so here we have an initial side, terminal side, so we're rotating like this. The center of the rotation we'll put at the vertex of the angle. And here's our pre-image set here, A, B, and C. And let's make that just a little bigger. You see the labeling. Okay, so B is close to the center, so it is going to not travel as far. C is the one that's way out here, far away from the center, so it's going to travel the most. A is somewhere in between. So first step is, we'll just do this for A. We mark a circle centered at the center of the rotation going through A. So I put my compass, put the pointing end here at the center, and the marking end at A, and start there and go along this way. And I can kind of eyeball it and know it's going to be about over in here somewhere rather than up here. And so I can go out just do this part of the arc and go a little bit further than I think I need to go. If I want, I could do the full circle. That may help me keep track of it. Now, the thing to notice is we're going to use a property here. Notice that if I connect up the center to A, it's the same as connecting up the center to both K and L, where these are the points of intersection here. Actually, I take that back what I said earlier. I said you want to just mark over here. That's going to be good defining A prime, but we also need to mark over here in this arc. So actually, you just want to make the full circle here. And it should then cross this angle twice, once on each side and each ray of the angle. Now, what we know is that these segments from center to K, from center to L, and from center to A are all congruent. Furthermore, if we know, let's see, then look at this distance from K to L. Look at, there's a triangle right here. Well, if I make sure that the point A prime is on this circle, I will get this side, this side, this side, and this side. Well, just going to K and L there. Those are all four be congruent to each other. If I can just make sure that this one and this one are congruent as well, then I've got two triangles here. Here's a triangle there, and there's one over here with this side here. And those two are congruent by side, 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 which makes the angle in the middle congruent as well. So that's where we're going to do it. Now, if you had a protractor, you might measure this angle and just mark this angle off with a protractor. But if we're going to do it with a compass and straight edge, we're not allowed to use a protractor. Then we've just got to do it by measuring distances only, not measuring them in terms of seeing how many centimeters it is, but just by marking congruent distances. That's what a compass does. So once we have this circle, so let's review again. Start by taking the center, go to point A, set your compass that distance, draw a full circle. Find the 2 points K and L where that touches the angle, and set your compass to that. So say, put your pointing end at L and the marking end at K. You'll make a little bitty tiny mark right there at K to make sure you got it set right. Then come over here, put the pointing end at A, and draw an arc here. Now actually, if you draw the full circle, it's probably going to touch this circle twice here. Once will be once will be A prime if you rotate in the positive direction, and once will be if you rotate in the negative direction. This is rotating the positive direction, so that means we're going around the circle this way. So if we start at A and continue around, we're going to come to this point here. So A prime is actually here. And then guess what? You do the same thing for B prime. You make a circle centered at B, find the distance between these 2 points here, mark a circle centered at B, and where they touch right there is B prime. And then C prime, you do the same thing. Make a circle all the way around through C, find out where it touches here, set your compass to that length, mark a circle off centered at C, and C prime is going to be down here. And so there is your image right there. Where these two circles meet is B prime. Where these two circles meet is A prime. And where these two circles meet down here is C prime. Just be sure that when it's all said and done, you have it rotating in the correct direction. Now, how can we check this with tracing paper? Okay, put your tracing paper on top of this picture, and what you want to do is first of all, mark the center and draw the initial ray. Don't draw both rays, just draw the first one. So just trace this ray. Then, using your straight edge to make sure you got straight segments here, trace the initial figure. Then what you want to do is hold your pencil right here on the center of rotation, because notice that's the only point in the plane that's actually fixed by a rotation. The only point in the plane fixed by rotation is the center of the rotation. So hold your pencil there and spin the transparency or the tracing paper. Spin it without spinning the underneath paper, so that this ray here will spin from initial side. It will spin to be on top of the terminal ray. As it does, you're going to see the trace here spin around, and whenever you finish, if you land there, it should land on top of your image here. And so that gives you a way to see your image and check it using tracing paper. Now, it turns out that rotations with a grid are generally not. A rectangular grid doesn't really help a lot. A polar grid helps quite a bit if they're rotating about the origin. But there are a couple of rotations, actually multiples of 90 degrees, that a grid can kind of help us. So let's take a look here. If we want to rotate, this is 90-degree angle. Okay? So we want to rotate about the origin. Now notice we're going 1, 2, 3, 4 up and 2 to the left. Okay? Where is the image going to be? Well, it's going to be okay, instead of up 4, left 2, this is going to be left 4, down 2. So image is going to be down here. That's going to make a right angle here. See, this one has a slope of 4 over negative 2, has a slope of negative 2, right one down 2, negative 2. And this one has a slope of positive 1/2, right 2 up 1, or right 1 up 1/2. Or if you go all the way to the origin, right 4 up 2. So how did that compare? Let's see if I can write that down. So the one connecting here was right 2 and down 4. That was basically the vector to the origin. And the other one, the vector, well, from the origin is left 4 and down 2. So you notice you get a switch, but we also get a sign change there. And so we get that image there. If you make it negative 90 degrees, and this is about the origin here, okay, then notice that this one is going, again, it's the vector to the origin is 2, negative 4. Okay, and the vector from the origin to the image, A, is right 4 up 2. So again, you're seeing a switch. This time the sign changes on the first one. Well, on the second one here to the first one here. Okay, and again you get perpendicular there. So it's a little bit harder than the last one, but okay. Now if you will do let's see. I don't like the font that we're using here. There we go. Now if you make it 180 degrees, pi radians, that one's kind of interesting about the origin, because notice what happens here. Let's just take the point here. Well, let's actually maybe I should look back. Hang on a minute. Let's look back here. Let's actually look what happens to the actual point, maybe. So instead of thinking these as vectors, maybe it may be better to look at this as a point. So let's take the point A. A is actually the point negative 2, 4 as a point. And A prime is negative 4, positive, negative 4, negative 2. This is a 90-degree rotation. See what happens to a negative 90-degree rotation. Okay, A prime is here. It's at 4, 2. And then what happens with a 180-degree rotation? The 180-degree rotation particularly is kind of nice. A is again at negative 2, 4. A prime is here is at 2, negative 4. So notice here the line connecting straight to the origin is going to keep going straight on to the image there when it's 180 degrees. So straight angle there is what's formed. And so what was that? A was 2, negative 4. So this is going to take xy is going to be sent to negative x, negative y. They both just change sign. This one's going to take 90 degrees, is going to take xy and send it to negative y, x. And this negative 90 degrees is going to take xy and send it to y, negative x. So kind of interesting what actually happens to the x and y here on these particular types of rotations about the origin. Now remember, these are specifically rotations about the origin, and we only did certain specific ones. This particular one right here is kind of nice. 180-degree rotation about the origin can be done very quickly by just switching the signs on both x and y. This one here, 90 degrees, you're going to basically switch x and y and change the sign of one of them. So kind of interesting how that turns out. Other rotations on a grid and using a coordinate system are more complicated. We'll come back to that in a little bit in a later video.